NASA launched the New Horizons spacecraft in 2006 to investigate Pluto, the solar system's eighth planet at the time. New Horizons arrived at Pluto after a 9-year journey, becoming the first spacecraft to visit the far-flung world. The probe has now traveled 50 astronomical units away from Earth. That's almost 7.5 billion kilometers. However, scientists are still analyzing the data from Pluto flyby, and recent research suggests that Pluto is living and not as calm as it appears. But how did scientists arrive at this conclusion? What was the unusual thing they spotted in the New Horizons probe images? And, perhaps most crucially, does this find point to the possibility of life in Pluto? Hello there, and welcome back to the Discover Space channel, where we bring you the most amazing space facts you won't want to miss. When other objects of comparable size were discovered in the Kuiper Belt in 1990s, Pluto's planetary status was called into question. Pluto was classed as a dwarf planet by the International Astronomical Union in 2006. That didn't make it any less of a target for human exploration. The images taken by New Horizons have revealed something utterly unexpected and amazing that has never been seen before on any other planet in the solar system. Many rough volcanoes erected into various heights have been seen on Pluto's surface in photographs. Surprisingly, there were no impact craters from asteroids or meteors nearby, unlike the rest of the planet. There were also no sign of plate tectonic activity, which is critical for mountain creation on Earth. All of these indicators combined suggested that the surface was produced following a recent geologic disturbance, presumably a volcanic explosion that occurred within the last 2 billion years. Okay, I get that 2 billion years seems like a long period, but in the grand scheme of things, it's not that long and may be regarded as a recent event. Two peaks rising over Pluto's surface have perplexed planetary scientists for years when it comes to the dwarf planet's volcanic features. The first is Right Mons, a mountainous formation. The surface object is about 150 kilometers broad, rises approximately 5 kilometers above the surface, and has a center depression nearly 50 kilometers large. The second feature, Picard Mons, rises to about 7 kilometers in height and spans approximately 225 kilometers. Even though Pluto's diameter is only 1/6 that of Earth, its overall volume is comparable to that of Hawaii's Mauna Loa, one of our planet's largest volcanoes. These massive surface structures are located near the southwest edge of the Sputnik Planitia ice sheet, which is a lighter region to the left of Pluto's renowned heart-shaped feature, and were discovered in July 2015 by the New Horizons mission. This sheet is dominated by folds and rises that look as wrinkles over a smooth ice surface, and is characterized by an ancient impact basin over 1,000 kilometers wide. There are multiple volcanic domes in this area, with the majority of them merging into one larger dome. Researchers assume that many eruption sites close to each other must have fueled the construction of such terrain after carefully scrutinizing the photographs acquired by the New Horizons. And it's possible that the ice blasted during the subsequent cryovolcanic eruptions blanketed the entire region. A thorough investigation also reveals that the surface material in this region is largely water ice, rather than nitrogen or methane ice, as is common in other parts of the planet's surface. This adds to the evidence that cryovolcanic activity is indeed possible. Volcanoes, on the other hand, require a continual heat source to produce eruptions. On Earth, For example, the primary source of energy for volcanism is radioactive decay in the Earth's interior. On other circumstances, the tug and pull induced by gravitational interaction with big surrounding objects might cause this heat. That is the primary cause of Io's volcanic activity. But, as far as Pluto is concerned, neither of these ideas fits. Pluto's neighbors aren't powerful enough to generate enough tidal and gravitational forces to warm its interior. And the rocky stuff inside its core isn't dense enough to generate heat from radioactivity. Pluto, on the other hand, has a typical surface temperature of almost negative 240 degrees Celsius, with a rock-like hard-frozen surface that cannot melt quickly so far from the sun, even with various heat sources. So, where does all of this heat originate? Given all the evidence, and only probable hypotheses is that the dwarf planet still has leftover heat from its formation trapped within it, most likely in a deep sea beneath its frozen crust. Oceans have been discovered on several frozen worlds in the solar system, including Saturn's moon, Enceladus, and Jupiter's moon, Europa. Enceladus has also demonstrated regular cryovolcanism by ejecting icy material into space and renewing one of Saturn's rings. Nonetheless, other than Pluto, no other planet in the solar system has seen massive heaps of frozen volcanoes spread out in a field and merging to recycle an icy surface. But it's important to remember that the New Horizons spacecraft only flew past and surveyed the region for one day. As a result, it's still unclear if Pluto's cryovolcanism is still active or if the unusualized volcanoes have fallen dormant. And if it's still active, it increases the chance of finding a liquid ocean and, who knows, maybe even life. Thank you so much for tuning in with us for yet another cosmic adventure. Comment down which one you want to explore next, and we shall see you then.